Okay, hi there. Welcome to my video about periodic trends. So this is going to be about pretty much the way the periodic table is organized, so that the way the elements are organized on the periodic table, so that they form patterns called periodic trends. So in this way, you can pretty much tell, for example, which atom of an element has a higher electronegativity than another, or larger atomic radius, or something like that. So first, I'll start with electronegativity. So electronegativity is the likelihood of an atom to attract and take electrons from another atom when forming an ionic bond. And electronegativity is measured in Paulings, just for your information. So on the periodic table, atoms are arranged so that electronegativity increases as you move to the right on the periodic table. So it increases this way. And just for future reference, whichever way the arrow is pointing on my diagrams, that's the way it increases. So it increases that way, and it also increases as you go from down to up, like this. So it increases as you go to the right, and increases as you go up. And so what this means is that if you ignore the bottom row, which, I don't know, I'm ignoring the bottom row for this. So cesium has the lowest electronegativity, and fluorine all the way up here has the highest. And also, just for future reference, these are the noble gases, and they don't have any electronegativity because they don't form an ionic bond. They just don't form any bonds at all because they already have 8 valence electrons. So anyway, that's how you can find out which atom has a higher electronegativity, and now I'll show you some examples. So if you want to choose which element is more electronegative, between rubidium and strontium, you can do that pretty easily using the periodic trends, because you know that strontium, which is right here, is further to the right on the periodic table than rubidium is. So therefore you know that strontium has a higher electronegativity. And you can also do this with another pair, like let's say boron and aluminum. Since boron is higher, and since it increases as you go up, boron has the higher electronegativity out of those two. So there you go, that's electronegativity. Now we'll move on to to atomic radius. So atomic radius is defined by how far away an atom is how far away an atom is from neighboring atoms. So it's half the distance between the nucleus and of the adjacent atoms, which is the radius. So just as for the periodic trend, atomic radius decreases as you go from left to right. So it increases as you go from right to left, so it goes like this. And it also increases as you go from up to down. It increases, so like this. So yeah, the arrow shows it increasing. There you go, that's that. And we can also look at some examples for this one too. So we can use potassium and rubidium as an example. So potassium's here, rubidium's here. So you know pretty easily which one has the bigger atomic radius, because you know it's rubidium, because since it increases up to down, rubidium's further down than potassium, so rubidium has a higher atomic radius. And you can do the same thing, let's say, I don't know, oxygen and fluorine, which are right here. Oxygen is further left, and because it increases as you go left, oxygen has a higher atomic radius. Pretty easy to figure out which one has the higher atomic radius using this method. Let's move on here to it's pretty similar to atomic radius. It's called ionic radius. So it's measured the same way as atomic radius, but the difference is that it's the radius of the atom after it forms an ionic bond. So the trend is going to be different because of that. So it increases as you move from right to left, but only for the atoms that have a positive ion, that form a positive ion. So when an atom forms an ionic bond, it can either gain or lose electrons. And so the atoms that have a positive ionic bond will lose electrons because electrons have a negative charge, and so when it loses the negative charge, it gains a positive charge. So all the atoms that that lose electrons that form a positive ion, which is everything to the left of nitrogen. So the periodic trend with that is that it goes from right to left. And then the ionic radius also increases up to down. So the same thing with atomic radius. But something to mention is that when it starts becoming negative, when it gains electrons when forming an ion, which starts at nitrogen, so that means that nitrogen is going to be larger than carbon, so the trend doesn't hold. So pretty much dividing line is at nitrogen, so nitrogen is actually larger than carbon, and then for the rest of these three groups here, the trend is the same. It's just that the elements of nitrogen is larger than carbon, so this trend doesn't hold up. And so just a few more examples, I suppose. I don't know, it doesn't really matter, but so let's just say aluminum and silicon as an example. So because aluminum is further to the left of the than silicon is, it'll have a larger ionic radius. And then another example we could do is something like nitrogen and carbon. Well, you'd think because of this trend that nitrogen would actually have a smaller ionic radius than carbon. It actually isn't. Nitrogen actually has a bigger ionic radius. Just keep that in mind. So there you go. It also works up to down, same as atomic radius. So potassium and rubidium. Rubidium is going to have a larger ionic radius because it is further down on the periodic table. Okay, yes, there's one more I want to cover, and that is ionization energy. Yay, so ionization energy is the energy required to remove an electron from the gaseous form of the element. So, yes, it's pretty self-explanatory, I think. Whenever an atom loses an electron, the energy that required is the ionization energy. So, there's multiple forms of ionization energy, which there's the first ionization energy, which I'm going to be talking about. And then there's the second ionization energy, which is the energy required to remove the second electron, but I'm not going to really be talking about that. So anyway, ionization energy will increase as you move left to right, like this. That increases. And then ionization energy will also increase as you move down to up, or decrease as you move up to down. So, like that, there's our little chart, like we did for the others. And yeah, it behaves pretty much the same as all the others. So, cesium is the lowest, helium is the highest. And also something else to mention, hydrogen doesn't really follow the trend because it actually has a high ionization energy. And that's because it only has one electron, so it does not want to lose the one electron it has, because instead of going down to a full valence shell when it loses the electron, it just moves down to nothing. So that's why it doesn't follow the trend. But why cesium's the lowest, because it only has one electron in its valence shell, so it wants to lose that one electron so it can have a full valence shell. And also, that one electron is furthest away from the nucleus. And so that means that it doesn't have as strong of a pull as, say, lithium, which the valence electron, well, it is only one valence electron and it wants to get rid of it. It has a higher pull to the nucleus because it's closer. Hopefully that made sense. So I'll try to draw a picture to demonstrate it. So here you have cesium, and here you have lithium. So let's say cesium's valence electron is all the way out here, and lithium's is right here. Both have one valence electron, but cesium's is further away, so that means that it doesn't have as strong of a pull towards the nucleus as lithium. So anyway, that's why. And so, yeah, pretty self-explanatory. You can do some examples. Phosphorus and sulfur. Sulfur is going to have a higher ionization energy because it's further to the right. Magnesium and calcium Magnesium is going to have a higher ionization energy because it is further up on the periodic table. So that's all for this video. Thanks for watching it, I guess. Hope you learned something about periodic trends. Bye.